top. We're just going to make a drawing of a parabola like we have seen before. So here's a parabola. There are some parts of the parabola we're used to seeing, and then some things that are new to us. Okay? So the parts of the parabola that we're used to seeing, what are some things that when we plotted parabolas before we would mark on the graph as important parts of the parabola? Matt? The vertex. So one of them is the vertex. Cody?
The zeros.
Good. The zeros if it crossed the x-axis. I'm not going to mark that on here, not because that's not valid, because I don't even need an x-y axis on here right now. Okay? But that's a totally valid point. Let's see who hasn't given me any points. You've talked today, right? Bailey.
The axis of symmetry.
Good. The axis of symmetry. Okay. So those are the main things we're going to focus on from the past, is identifying the vertex, the axis of symmetry. Okay. What are the new things that we now learned, like from a geometrical perspective, are necessary to actually build a parabola? Helen? The focus is one. So we know that focus is some point that our parabola ends up wrapping around because of its relationship to it. So somewhere in here, right, there is a focus. What else? Does anybody remember what I called that line you were folding from? Good, the directrix, yeah. All right, now we used stretches and compressions in the past, or plugging in points to determine how wide or how narrow our parabola was. But now that we know that the focus exists for a parabola, we can actually dictate how wide and how narrow our parabola is based on a distance from points that are at the same height as the focus, the length of this line that goes across here. Okay? So then, of course, that line has a name, okay? That segment. It is called lattice rectum. Yeah, you can giggle if you have to. I'll figure. All right, so that's the name of it. So what that's going to do for us is now when we plot parabolas, vertex and axis of symmetry just like before. Okay? New, maybe somewhat annoying type of thing, we have to go a little further and determine the focus and the directrix. Okay? However, we don't need to plot points or think about stretches and compressions to know how wide or narrow to make our parabola, because we're just going to get this distance and figure it out. Okay? Yeah, Jenny.
I'm really sorry. You may have already said this.
That's okay.
Like, what exactly is the point of the directrix? Like, why is that important?
So remember when you guys were folding your paper?
Yeah.
All the points that you made were on a certain line. Yours is actually a really good example of that, right? Remember how you asked me? I didn't put my points on the bottom of the paper, but I put them across this line right here. Is that okay? And does yours still work out to build a parabola like everyone else's? Yes. That's only because everyone in the room, when we built the parabola, though you selected a different number of points in a different location, you all selected points across a line, and that's why you're making a parabola that way, okay? And it would always make the vertex be specifically directly between the directrix and the focus. So if for some reason you were like, I'm not going to follow Miss Doll's directions, and you made like some slanted line and you used points on there, it would have just made your parabola go another direction, because it would have made sure that between that line and your focus is your vertex, and then the points would all surround the focus that way. Okay? Yeah, Alex.
Does it have two directions?
No. Are you thinking like ellipses or something, or hyperbola?
Like if you were to have a directrix on each side of the paper, like dots, and translate it over like before.
It's not going to give you a parabola. It might give you something different. Okay? But a parabola shape is only going to have one directrix because of its definition being that every point has to be the same distance from the focus as it is from the directrix. That would obviously change if you put in multiple directrixes. Okay? Yeah, I don't know. Some of the language in this chapter. Don't judge. Okay. Are we good? Yes? Okay. I hate this part so much. Okay. Oh, no, not that part. This part. All right. So, okay, before we cry. This is the chart I don't memorize. Okay. Look at it. Really? Right? Look at it. Man. Okay. All like there's a lot. Yeah, this is in the lots of equation stuff section of the paper. Yeah. Do you see why I called it that now? Yeah. Okay, yeah. So there's two types of equations. So this part is important to me. Okay? My opinion, right? Okay. This part is important to me. I do need to understand that there are two different types of equations for parabolas. Okay, let's call this equation number 1 and equation number 2. Which one is the one that we are used to dealing with? Equation number 1. Y equals our x's squared, which means this equation produces what kind of parabola? Which direction can the parabola face with this equation? Cody? Up or down. Okay? Here you're going to get this or this. Okay? This little gem right here, you already knew. Okay? The vertex is at HK. It's good to know something here. Okay? All this other information, I don't memorize this stuff. I don't know. How do you remember when it's a plus, when it's a minus, the A, positive, negative? I don't know. Okay. Here's what's basically going on. Notice that there's a column in the chart for focus, for directrix, and for axis of symmetry. First of all, do we recognize this? What is the 1 over 4a? The distance between the vertex of the parabola and the focus, or the vertex of the parabola and the directrix. So do you notice that these distances are used specifically to figure out the directrix and the focus? And that those distances are being added or subtracted onto something you already had to get to the directrix or the focus? So the way I see it is this. When I look at a parabola like this, I know that my vertex is right there. I know that my focus is supposed to end up somewhere up there. I know my directrix is supposed to end up down here. And I have to memorize the 1 over 4a thing. So what I have memorized in my head is I know this version of the equation. I know the vertex is hk. And I know 1 over 4a is going to give me the distances I need between the vertex and focus and vertex and directrix. Okay? But then I just figure it out myself. I don't need this to tell me the vertex or the focus is going to be h comma k plus 1 over 4a. Okay? I just go over here and say, well, if I know that my vertex is at, say, like 2, 3, okay, then the focus is at 2 comma, and then I just take my 1 over 4a calculation and I add it with my 3 to put it a little bit higher than what it was, right? That distance. Okay? So what I'm saying is you can totally figure it out without having to memorize all of this stuff here. Okay? If you memorize all of this stuff here, the pluses and minuses are strategically located. So if this is positive or negative, it works out the right way to move the directrix or the focus up or down from the vertex. But if you already know how this works, and you know that if the parabola is like this, the focus is actually underneath the vertex and the directrix is actually above it, then there's no reason for you to have to memorize and you have to subtract this, and when you plug in a negative, it's actually going to add it. You just have to know 1 over 4a is like the magic distance to get to the other things that you need. Okay? So do you see what I mean by, like, I hate this little chart? But some of you might just love it, so that's okay. All right? All right, so parabola number 2. Which direction do you think these kinds of parabolas face? Yeah, left or right. Okay, so this or this. Okay? Vertex is still hk, but notice y is in the parentheses being squared, and what is attached to y, the h value or the k value? K value. X always goes with h, y always goes with k. Don't pull the numbers from the wrong place in your equation. Okay? Then look, it's all the same stuff that was going on before. All right? Again, all I want to know, I don't memorize any of that stuff. Okay? I just know that in this, the focus is going to be over here. The directrix is going to be over here. So when I find my vertex, I'm going to add a distance to the x-coordinate here to get the focus, subtract it to get the directrix. Okay? We'll see more about how that works as we do some examples. All right, one small equation that you need at the bottom that this is covering up, sorry. This I have to know too. So I know, like, the equations. I know 1 over 4a is the distance from the vertex to the focus and also the vertex to the directrix. And that 1 over a is the length of the lattice rectum, like how wide the parabola is. Okay? But I don't memorize these. Okay? They confuse me. All right. Is this okay for Lots of equation stuff. Yeah, Mincha?
Is it 1 over 4a or is it 1 plus?
It's 1 over 4a. The a is definitely in the denominator. Okay. Are we okay with this? It's a lot of information. Anybody need the screen longer? Okay. But I think that basic information is, like I said, for me, this is what it boils down to for me. I know that this is some sort of vertical parabola. I know that this is some sort of horizontal parabola. I know that 1 over 4a, and I kind of ignore the positive or negative value of a, okay? Because I'm going to move it the direction I need to move it, depending on focus or directrix, and I just look at the picture to help. That this is the distance from vertex to focus or vertex to directrix. Okay? That's like what I know. And I do have to know the latus rectum thing. Yeah. Okay. So you have a choice. You can memorize that chart of information, or every time you get a parabola problem, you can draw a little sketch and just know this. I don't know. I totally think this wins, but that's completely my opinion. Oh, sorry. Focus. Directrix. Yes.